Hello students. So today we will study the projectile motion. So let us see what is projectile motion. So projectile motion is basically the example of the 2D motion, means two-dimensional motion, right? Here in this the particle will be moving in such a way so that its x and y coordinate both will be changing together, right? So let us take one case where we will observe the projectile motion, right? So here xy coordinate I have taken and this is the origin, right? So I have taken one ball, right? I have taken one ball here at origin and I am going to throw this ball obliquely from the origin. Obliquely means this ball is thrown from horizontal at certain angle, not in the horizontal direction, not in vertical direction, at certain angle, right? So this is the oblique throw, right? So let us consider its initial speed of throw is u, right? And the angle of projection is theta, which is the angle from the horizontal, right? So if we throw this ball, so since here acceleration due to gravity is acting in downward direction, so due to the effect of this acceleration due to gravity, this particle will move in a particular manner as shown here, right? So this motion of the body will be called as the projectile motion and this object will be called as projectile, right? So this is the thing about the projectile motion. Now in this projectile motion, what are the parameters which we are going to calculate? So let us see. Since initially this particle is moving in horizontal direction as well as vertical direction, but after certain time its vertical motion is stopped at a point. That point is called as maximum height point, right? And after that point this particle will start moving in the downward direction, right? So one parameter we will calculate what is maximum height of this projectile. What is another one parameter? After certain time again this projectile will hit at the ground level, right? So from initial position to the position where it hit the ground again, that separation is called as horizontal range. It is denoted by r. So this also we need to calculate. Now some more parameters. From this initial point to maximum height point, the time taken is called as ascending time and this is denoted by ta, right? Then again from maximum height to this point, time taken by the particle is known as descending time and denoted by Td, and the overall time means this ascending time plus descending time is called as time of flight and denoted by Tf, right? Why it is called time of flight? Because in this duration particle will be in air, right? That's why it is called time of flight. So these are the 5 parameters we will calculate. Apart from this, one more parameter we will find here, that is equation of this path of projectile, that is called as equation of trajectory. So overall 6 things we will find here in the projectile motion. So let us start our calculation, right? First we will note down the given things, right? So in given things, there is the initial velocity, say u naught. In vector form I am writing, right? Because this is the motion in plane, so 2 coordinates will be there, so I will write it in the vector form, right? So initial velocity vector u naught is given as its horizontal component, that is u cos theta, right? And it is in I cap direction. This x direction we denote by I cap, unit vector, right? Then plus u sin theta, that is the vertical component of this initial velocity, that is j cap, right? So this is given initial velocity vector. Now what else is given here, right? Acceleration due to gravity is given, and this acceleration due to gravity throughout the motion we will consider constant, at each and every point, right? So this total acceleration vector we will write here, which is constant only, right? There is no acceleration in the horizontal direction, so we will write 0 I cap, and this acceleration is acting vertically downward direction, so we will write minus g j cap, right? So these two are the given things. Now from here you can see कि this acceleration is constant throughout the motion, so we can analyze this motion under the condition of uniformly accelerated motion, because this acceleration is going to be constant throughout the motion. And as we all know कि for uniformly accelerated motion we can use equations of motion, right? We can use equations of motion. And don't you think कि equation of motion is applicable only for motion on a straight line, right? It can be applicable in 2D as well as in 3D also, right? But just we need to write those equations of motion in vector format, right? So to find out these parameters we will use two equations of motion, that is first equation of motion and second equation of motion. Why? Because we will assume that कि at certain time t equal to t, particle is reached here, right? So when particle is displaced from here to here, so it will move by certain distance in the x direction, say it is x, and certain distance in y direction, say it is y, right? So net displacement we can write xi cap and yj cap. Now because acceleration is acting, so its initial velocity will also be continuously changing. To say its velocity after certain time will become v, right? V velocity. It have also two components, right? Horizontal component and vertical component. Clear? So we need to write the displacement vector and velocity vector. To write the velocity vector, we will use first equation of motion, that is v vector equal to u naught vector plus a vector into t. This is the first equation of motion in vector form, right? So this is the velocity vector at any time t. Initial velocity is given as, here we can write in vector form, that is u cos theta I cap and plus u sin theta j cap. This is initial velocity vector plus a. So a value, I component is 0, only j component is there, so we will write it minus g into t and j cap. So we will club I components and j components. So I component I am writing u cos theta minus gt, sorry, this is j component, so u cos theta I cap plus u sin theta and minus gt whole to j cap, right? So this is equation 1 I am assuming, right? And this is the velocity vector at any time t equal to t. Now again displacement vector we want to find, so we will write the second equation of motion in vector form. So that is s vector equal to u vector into t plus half a vector into t square. So this is second equation of motion, which you use s equal to ut plus half at square. Here we are using in vector form, right? So we will put it here. This s vector is equal to initial velocity vector, we will put here, that is u cos theta into t, this will be I cap, plus u sin theta into t and j cap. Then a value we will put minus gj cap, so here it will become minus g by 2 into t square into j cap. So again I component and j component we will club, so u cos theta into t I cap plus u sin theta into t minus g by 2 t square into j cap. So this is the net displacement vector after certain time. Let it be equation 2, right? So from these velocity vectors and displacement vectors, easily we can write x component of velocity at any time and y component of velocity at any time by comparing the coefficients. x component of velocity will be equal to u cos theta, and it is independent of time, means there is no change in velocity in x direction because there is no acceleration in x direction. And this is y component of velocity which is depending on the time, means with the time this velocity will change, right? Here you can say displacement is continuously changing, it is the function of time in x direction and y direction both, right? That's why this particle is moving in x direction as well as in y direction, right? So our target is to calculate these parameters. So let us see what conditions we will apply to find out these parameters. First we will calculate the maximum height. So as you can see, when this particle will reach at maximum height, its velocity must become zero and not whole velocity, only vertical component. That's why this particle stopped going up. After certain point it will stop, then again next moment it will start coming down, means at a particular moment this vertical component of the velocity will be zero here. So I am going to put Vy equal to 0, means vertical component of velocity we will equate to 0. So from there we will get the time. Let us see what is the vertical component of velocity, that is this one, u sin theta minus gt, right? So u sin theta minus gt equal to 0. So we will get the time, that is equal to u sin theta divided by g, and this time is nothing but this is ascending time, because in this time particle is reached up to maximum height, right? So this is ascending time. Now in this much time, what is the vertical displacement of this particle? That is maximum height only, means since at t equal to ta, the y displacement will become h, means maximum height, or y displacement is this one, because this is net displacement vector and this is the y component of displacement, right? So in this displacement we will put this y equal to h and t equal to ta, which value written here, right? So h equal to u sin theta into t value we will put this u sin theta by g, and minus g by 2 t square, means square of this u square sin square theta by g square. So 1g will get cancelled, and if you see it, so same expression is written here also, just 1 by 2. So whole value minus half of that value, it will become half of the value, right? That is u square sin square theta divided by 2g, and this is the expression of maximum height which we have derived here, right? So first term we have got. Now our target is to find out the range. Okay, so board is filled. Now we will clear the board. Now next we want to find out the range. Now again we will find some condition. Here you see, when the particle is traveling from here to here, y displacement first increases, then decreases and becomes 0, right? So we can put the condition ki y equal to 0. So we will get the time where the y displacement is 0. So y value means y displacement, again this expression we will take, that is u sin theta into t minus g by 2 t square, this will equate to 0, right? So taking t common, right, inside u sin theta minus g by 2 into t equal to 0. So here two things in product, that is equal to 0. So first can be 0 or second can be 0, right? So here you see t equal to 0, y displacement is also 0. Why? This expression is mathematically correct, because at t equal to 0 particle was having displacement 0 in the y direction. It was starting its motion, and again at t equal to this much time this particle again will be at y equal to 0 displacement. So this one will be useful for us, right? So we will equate to 0, means u sin theta minus g by 2 into t equal to 0. So from here t equal to we will get 2u sin theta divided by g, and this time is nothing but this is the time of flight, because this is the time taken by the particle to travel this much distance, right? So in this duration particle is in air, that's why this is time of flight. Now in this time how much is the horizontal displacement, that will be the range. So again we will take next expression horizontal displacement and we will put the time equal to time of flight, so we will get the expression of range. Okay, so here x direction displacement is u cos theta into t. Now t value this we will put u cos theta into t equal to 2u sin theta divided by g. So 2 sin theta into cos theta, it will become sin 2 theta, and u into u square into sin 2 theta divided by g, and this x now will become equal to range, right? So this is the expression for range, horizontal range of the projectile. This we have got two expressions we got, and time of flight also we got, and ascending time. Now next, how you can get descending time? From here td will be equal to tf minus ta. Now tf 2u sin theta divided by g minus u sin theta divided by g, right? And if we subtract this, so we will get u sin theta by g, and by seeing all the times we will get to know the value of time of ascent is equal to time of descent, and that is equal to half of time of flight. So this is the relation between ascending time, descending time, and time of flight, right? So 5 parameters we have calculated, 3 to 5. Last one is equation of trajectory. So how we will calculate the equation of trajectory? Equation of trajectory means nothing but relation between x and y, right? So we have x expression, that is u cos theta into t, and y expression, that is u sin theta into t minus g by 2 t square. So here t is the variable. If we will eliminate this t from these two equations, so we will get one relation between x and y, that will be called as equation of trajectory. So we can write t equal to x by u cos theta, and we will put it in the second equation. So y equal to u sin theta into x by u cos theta minus g by 2 and square of this, that will be equal to x square divided by u square cos square theta, right? So if you simplify, you will get you cancel tan theta into x minus g by 2 u square cos square theta into x square, right? So this is the equation of trajectory. This is equation of trajectory. And if we want to find out what is the nature of this curve, so we can compare this equation, with this y equal to ax minus bx square. This equation is written in this format, y equal to ax minus bx square. So this is the standard equation for inverted parabola. So we can say that the equation of trajectory is the inverted parabola, right? So from here we have got each and everything which are there in the projectile motion. So hopefully you are able to understand the projectile motion completely. Thank you.